Hi everyone. Today we're going to evaluate more indefinite integrals. Let us make a review first. In our last video, we studied about integration formulas. Also, we studied about properties of indefinite integrals. Now we're going to evaluate the following integrals using the formulas and also the properties of indefinite integrals. We have here 5 sample problems. Let's begin with problem number 1. Let us evaluate the integral of the square root of x, this quantity is raised to 3, dx. For our solution, let us rewrite our integrand into fractional exponent. So we have here the integral of x raised to 3 over 2 dx. From here, let us use the power rule of integral. The formula is here. So we have now x raised to 3 over 2 plus 1 all over 3 over 2 plus 1. This 3 over 2 plus 1 is equal to 5 over 2. So we can simplify this into x raised to 5 over 2 all over 5 over 2. Simplifying this complex fraction, we can flip our denominator fraction into 2 over 5. So the 2 becomes the coefficient of the numerator. So we have 2x raised to 5 over 2 all over 5. Let us show now that this x raised to 5 over 2 is equal to x raised to 4 over 2 times x raised to 1/2. This expression here can be simplified into x squared. While this x raised to 1 over 2, let us convert this again into radical form. So we have now 2x squared square root of x all over 5. Then we will add the plus c. This is now the final answer. Let us copy this answer opposite problem number 1. Let's go now to problem number 2. The integral of 4 all over the quantity x squared plus 1 dx. In here, we're going to factor out the constant 4 or that numerator outside the integral sign. So we have now 4 times the integral of 1 all over x squared plus 1 dx. We have a formula for this integral, and that is equal to the tangent inverse x plus c. So we can simplify this integral now into 4, that is the constant, times the tangent inverse of x. Then we will add plus c. This is now the final answer. Let us copy this opposite the problem number 2. Let's go now to problem number 3. The integral of tangent x times cosine x dx. We don't have the direct formula for the integral of tangent x cosine x dx. What we're going to do here, we're going to simplify the trigonometric functions here by showing that the tangent x is equal to sine x over cosine x. So we have this expression now. And from here, we can cancel this cosine x along with that denominator cosine x. Rewriting our integral, so we have the integral of sine x dx. We have a formula for the integral of sine x dx that is equal to negative cosine x plus c. And this value we will write here. This is now the final answer. We will copy this opposite problem number 3. Let's go now to problem number 4. The integral of the quantity secant square x plus 1 dx. We're going to show that we're going to take the integral of the terms of the functions. So we have the integral of secant square x dx plus the integral of 1 dx. In here, we're going to use two formulas. The integral of secant square x dx, also the integral of the constant k dx. So we have now the tangent x for this integral plus the integral of 1 dx is 1x, or simply x. And then we will add the plus c. This is now the final answer for problem number 4. We will copy this answer opposite problem number 4. Let's solve now for problem number 5. Let us show that we are going to take the integral of each of the term of our function. So we have now the integral of ex dx minus the integral of 3x squared dx plus the integral of cosine x dx. So we're going to use three different integrals here. And these are the formulas that we're going to use. So the integral of ex dx is simply ex minus the constant 3 times x cubed over 3 plus the integral of cosine x is sin x. We can simplify this part by cancelling the 3 and the denominator 3. Rewriting again the answer, we have now e raised to x minus x cubed plus sin x. Then we will write the plus c. This is now the final answer for problem number 5. Let us copy this under problem number 5. I hope you learned something from this video. See you again next time.